Who knows if it's recording? Have to wait and see when it shows up on the other video, and we'll see whether it's working or not. Damn bastards. Irritating, I must admit. Windows 10 sucks. Thank you very much. I really do hate it. Dislike it very much. Nothing but problems so far. Very glitchy. And still waiting. You hate it. Ah, there, it's working. Okay. Dislike it very much. Nothing but problems so far. Very glitchy. Yes. And still waiting. All right. So hate it. Pause that. All right. So we're in business. All right. Anyway, so link below to the room if somebody wishes to defend conventional physics, which is kind of, horseshit. I mean, it's hard to say the word conventional because it's so unconventional in terms of it's all phantasmagorical mush. The more these people talk about this stuff, the more, I didn't even realize the quantum tunneling was all based on the Heisenberg uncertainty crap and the probability wave. And the fact that they've taken this probability wave and turned it into something that's real, that actually exists, and therefore the improbable is now possible because it's part of this stupid wave. So it's possible that a photon is actually shoots out of a laser and it goes to Pluto. Just pops up over there. No reason. It just all of a sudden appears there because it's somehow possible by their preposterously stupid math. And it's not possible. It's not going to happen ever. And they make it a possibility, and therefore they say now that there's a zillion photons in the sun, so they'll just say, well, a certain percentage of them magically appear on the opposite side of the atom. And so they tunnel through the atom. I mean, it's just crap. Absolute crap. It's a cause and effect universe. If a photon gains the energy or any other elemental piece to traverse an atom, it does it because something changed, something permitted it to happen. Either less energy was needed, which is the more logical explanation, and it was able to go through something because it needed less energy. The hill got lower for a minute, and it was able to roll up the hill far enough to get over the other side or something. And it's just, the way they explain it, it's just so bad. Well, anyway, that's just one complaint. But that's conventional physics, and so they really have turned this into a, they're making this unreal, these unreal aspects of their mathematics into real things and claiming they have real properties and real capacities that they can't demonstrate to exist. And instead of actually explaining why something happens, now they just use the quantum bullshit and just say quantum did it instead of actually finding out the real reason why something unusual happened. And it's bullshit. And none of it has anything to do with physics. It's not physical. And it's really bad. Yeah. So anyway, I didn't have an agenda. I mean, there's a video. I should have just made that video instead. I mean, I want to play one of these PBS videos where they talk about the two-slit experiment, and it's just another perfect example of the absolute lies that are a premise to this. It's so full of disinformation that you have to call it lies. I mean, there's no way they could be so obnoxious and so incorrect without it being intentional. This is what they're, they don't care about the truth. They just care about the facade, the bullshit they've built on this false foundation of mush. So they must preserve the mush because the mush is the foundation for everything they're doing, including all this collider crap. So the other video, I watched a couple of the Ken photographer guy videos, and they were just so bad. You know, hyperboloid and counter, whatever he calls it. Well, anyway, and then and it keeps using this word lack of inertia as if there's such a concept, and then he talks about something having. I should write down just a silly, you know, the conceptually silly words he uses all the time, but he uses a word for essence or existence. You know, implying that something like a black hole is really not a something anymore. And you're just like, well, yeah, it's obviously a something. It's obviously a someplace. And he doesn't even believe in a places anymore because he doesn't think time is fixed. And so it's just so loopy-doo. But the whole thing, he's caught up in it. He's using the old, you know, this stupid, idiotic model. So at least I know what he means by a coaxial now. So he's using the standard model of a photon, which is these two sine waves perpendicular to each other. One being a representation of its magnetic component, and the other one being a representation of its electrical component, as if these are different things when they're not. But regardless, and then drawing a straight line through it and calling that the middle of the coaxial cable, you see, and the shielding would be the two perpendicular sine waves. And then he's saying they're calling it a photon where all the null points, where the two sine waves collapse. But that's not the wavelength. The wavelength is twice as long. The null point is, there's technically 3 null points per photon in a sense. So as current science is counting photons, so he didn't even get that part. Even if he was correct in his analysis, he didn't get the analysis is incorrect in the sense that that's not how they're representing where the ton would be, because the ton is on the full wavelength, not a half wavelength, and there's a neutral every half wavelength. So anyway, it's just all very depressing. So I did consolidate some of my notes and was going to play with them a little bit, but that requires better vision than I have. So yeah, I still want to mess with this, you know, cutting it down to the real properties that exist and the ones that are actually changeable, the ones that are what's actually changing in the universe as it processes. And the fundamental argument is the only thing that's really changing is polarization. And you know, so the first argument would be that the photon isn't matter, it's force. And it happens to be a force we can see. So it's like magnetism, except we can see it. It's like, what else can I compare it to? I mean, there really aren't as many forces as they think, right? I mean, there are only really magnetism and light. What other force is there? There's other forms of radiation, so I guess you could say that, you know, but we think of those as photons, you know, from radio waves to cosmic rays. Those are photons, so we just consider all those a kind of light, but they're just force. So that's where they mush the line, because I think most people would say that radio waves are a lot like a force, and they might even think of cosmic rays as being kind of force-like. You know, or even X-rays. They don't think of them as photon-like, but it's all the same thing, just at a different frequency. And you know, polarization is the thing that gives it a meaning to matter. because matter converts polarization. So it's very hard for me to, I mean, I was trying to think of different ways of illustrating it, so I'll just try to illustrate verbally, and then I'll try maybe to draw it, but we'll see. But you can imagine if we just cut it down to two kinds of fish, blue fish and red fish, and matter was just a thing, a circle you could draw around any group of where the fish are. So the fish are always there. There's always these fish. They're always swimming in straight lines, and half of them are red and half of them are blue. And so that's what you start with, is just a mixture. And what's happening inside of something you might call matter is that one color fish goes in, going in straight line in a direction, and is converted into a fish going out some perpendicular direction. So what matter can do is store fish of a certain polarization color, and then release those fish in exchange them. Take some from the environment going this way, red fish going this way, and release what are technically blue fish that are now red fish going the other way. So they change the color of the fish. So they release the fish in a new direction. So if they take in red going this way and they hold those red, they'll release blue going straight, and they'll release red going perpendicular. So they're just exchanging the polarization, and so they can weight a section of the field with a predominance of one color of fish. So all the fish going this way, or a higher percentage of them, as it passes through matter, that percentage that are red will increase. So if you just think of it as a linear problem, there's a pure mixture of fish here. They go through matter, say I am matter, and what comes out here is not a pure mixture, is that now there's more red fish than blue fish going this way through me, and coming out this way would be more blue fish than red fish. So that's your field created by acceleration. So when you accelerate something, it has to give back the polarization, and it can either the reflection is the absorption. So it can either reflect, okay, the energy coming in, the force that it's absorbing, it's gaining acceleration, so it's eating polarization coming in from one end, and by absorbing it, it has to get rid of something it has, so it gets rid of the blue fish and a perpendicular, or it reflects it back the other way directly. So the reflection, when there's an acceleration, the reflection can either be realized as a perpendicular reflection or as a opposite reaction reflection. And the difference is something gaining velocity or getting hot when it interacts with photons, or something producing magnetism, like a conductor. So you can hit a conductor with photons and it will release magnetism as the reaction instead of the obvious reflection. The absorption is realized in the release of force perpendicular to the direction of the acceleration. Right. And so what a magnet is doing is basically just one of these material filters that's quite pure, and it reliably does this function of converting red fish to perpendicular red fish. So red fish goes in straight, it ends up going out perpendicular, and what would have been red fish going through ends up being blue fish. So all the fish that leave will be blue. because it left the blue ones alone that were in the, like I said, we just had two kinds. All the blue ones stayed blue. It converted the red ones into blue, so all blue goes out one end, and 50% red goes out the other side as the consequence. And all the red going through perpendicular goes straight through, because that's the way the filters are. The filters filter one direction, straight lines, and then the other ones are horizontal lines. So the filters are perpendicular, just like the consequence. And you can sort of understand bars going this way will let frisbees go through that are flat, and bars going this way will let frisbees go through that are this way, and no frisbee will get through both filters, kind of a thing, without having to be converted first. Yes, perpendicularly. So in a sense, an implication of this might be that magnets' true poles are actually left to right, is how the filters are aligned. The bars are going, how to put it, it's the sideways thing that has the filter, and the consequence is that something going through the middle realizes the effect of that filter, but as a perpendicular expression. But the main filter is actually filtering stuff going through it perpendicularly. But that's a whole nother complex thing I don't want to get into. I don't know if it's complex, but I mean, I haven't drawn it all out yet. So, but that's that's all that's happening in the universe. Matter just does this one thing, and it filters force. So when force comes in one form, blue, it'll make it leave perpendicularly as blue, or it will convert it into red, leaving backwards, or red going forward. But the point is, it converts the polarization, and that's all that's really changing. So there's not really, the fish aren't really, theoretically, you could almost argue the fish don't need to move. They just need to bump into each other to exchange the polarization. So in a sense, you could just say that the bumping distance is the speed of light. You know, how much time it takes for two things to bang into each other and exchange polarization is the only part of the thing that's happening in the universe. So there's no real speed of light. There's just the speed of bang, of hit, of the domino hitting the next domino. How long it takes the domino to fall would be the speed of light, that kind of thing. But there's no real traveling. But that's another point that doesn't need to be made. But I mean, that could be the truth of it. But both explanations have the same consequence. So if you make the bits actually moving the speed of light, it's the same consequence as making the interaction the speed of light. Means the same in the end, I think. I don't think there'd be no way to tell the difference between those two universes. I don't think, theoretically. Yeah. So yeah, that's the thing I'm still hung on, in the sense that trying to describe why matter, what exactly matter does to force to make it possible to collect it in such a way that it now behaves differently, and now that it does create a filter, that it does cause this change where kinetically it would normally go right through, and now it doesn't go normally right through. It reflects either perpendicular or in the opposite direction. Yeah. So in theory, what I'm saying is that the reflection, if the reflection is backward, I mean, if it's an opposite reaction reflection, then the color would stay the same. So blue going this way would hit my hand, let's say, and the fundamental change is that a blue would leave going this way. So now all of a sudden, the change in the universe is that there was blueness going this way, and now blueness is going this way. And if it converts it, then it would be that blue goes in this way and red comes out that way. Something like that. The blue is kept and a red is ejected. And I'm just confusing things by using blue and red because that just sounds like blue light and red light, and I don't mean to imply any frequencies. So I'm really talking about polarization and just finding a way to call this orientation blue and this orientation red. But yeah, probably already created a confusion. It's always handy for the brain to just keep using those two colors. I should have used orange and green or something. But yeah, too bad, didn't. Oh, it's getting a little hot up there in the fan on. Oof. All right. So yeah. So one of these videos, I will just do a beginning to end thing, just highlight all the things we know are the rules, because I think they are just so simple. You know, that all you really have is this force moving the speed of light. And the irritating thing is the fact that I just said the speed of light, and we should be saying the speed of force. And we should understand that light is just a manifestation of force. It's the same thing as magnetic rays. It's the same thing. It's just that we can see rays at a frequency and we can't see the rays that aren't at a frequency. So a magnet doesn't create rays at a frequency, so we don't see it. But it's the same thing being radiated by a magnet. And the same thing radiating down on us from gravity. There's a radiation level. There's more of this radiation of the particular polarization anyway coming down on us than is coming up from the bottom. So the proportion of red to green or orange to green is, there's more orange to green coming down than there is green to orange coming up, and that's what's pushing us down, is that imbalance in the polarization, which is the same thing as it's very similar to magnetism, but it's not the same requirement. But it's the point is that it's the polarization that's affecting the atomic parts, and most particularly the electrons. They're being accelerated by the force, whether the force be gravity or magnetism. And the imbalances in the force, that is, imbalances in the color, what most of the fish are on one side versus what most of the fish are on the other side, is what will decide which way the electron accelerates. So our electrons are essentially being accelerated in the down direction towards the center of the Earth by an imbalance in polarization that they're sensitive to. Yeah, and likely true of the proton. I'm just not sure about neutrons yet, but I would imagine. It's hard to put them in isolated gravity, so it's hard to see. You know, they're hard to put in containers and hard to watch. So I don't know if they have some kind of experiment where they've actually done that to see exactly what the what gravity does to a proton or a neutron. I suspect they have a problem with that because it's hard to build a container that can contain these things in a stable condition without their electrons. Yeah, so that's what I'm really working on, is what, again, just the mere presence of polarization may create the filter. So I mean, if all the things are, it's like a bicycle wheel. If they're all the spokes are moving the same way, you know, it ends up creating an automatically. If you put two of them next to each other, you end up creating bars quite quickly. If you have orientation of these fish, so if you can get a bunch of flat fish like a flounder, and they all swam equidistant from each other with the same flat plane, the same angle, you could sort of get the idea that that's going to create a filter. And that's what's happening inside matter, is matter's collecting fish of the same orientation. Now how, and it just does that in a simple way. Like I said, it accelerates, and as it accelerates, it expels. So it's just a matter of figuring out the dimensions of an electron, for example, whether it is a flat thing or a spherical thing. And I guess I would argue that I think what the simplest answer would be that it has to have more than one dimension, so that it could be like a gyroscope, the bars on a gyroscope, the cage of a gyroscope. You know, you do have these perhaps two or perhaps even three orbits in the three dimensions, and stuff can get absorbed in one dimension and releases energy in the other dimensions. But I'm just not sure if that model migrates sensibly, in the sense that they would end up, I think, not, it would end up not being correct, in the sense that I don't think you could get, you'd end up with an imbalance in their size. And so the bottom line is, I think they have to start that way. So I think they have three elements, but the three elements are orbiting around each other. So there's a tight loop in the middle, a wider loop in the next, and then the widest loop is in the third dimension. So they have, you know, representing the three colors probably too, in terms of frequency. So it's almost a doubling, and that's essentially what it's a halving. So from going from, you know, I should do the math on that, but you know, if you go from red light to blue light, so red you're at like 750 nanometers or so, 750 let's say is a round number, and then blue would be 400-ish, and so you would have yellow in between, let's say, and that would be a number in like the 600 range, 575 or something. Let's put 575. Yeah, and so those proportions could be the proportions of these orbits inside the electron that add up to a sphere, but they're obviously flat. They're like a solar system having, our solar system having three solar systems, you know, all perpendicular to each other. Yeah, so that works for me. Because they have to have these components, and there's no way that an electron, if it was flat, I can't come up with a logical explanation for the fact that it releases. Well, see, you can though, if you just do the polarization change thing. See, that's where it gets so tricky. Because you could say the acceleration, as I accelerate the wheel, that means the wheel gains velocity. So it's now compressing in the forward dimension. There's more stuff going this way than there is stuff going down the bottom loop. So the top loop is longer. Then the top is, say, let's longer than the going back part. And as you gain velocity, that would make sense because the road, there's more stuff coming in this way, so that fills the gap. So it's the shape of the electron is getting longer in a sense. And what's really happening is it's not releasing anything, it's just converting. So the idea would be is that it would absorb a color and then release something of another color forward. So the same number of fish are always moving in a direction. They're not changing the direction of them. So if 10 of them come in like behind a rocket or something, you push 10 fish up. And there's still 10 fish coming out the front. It's just that their polarization has changed. And therefore their significance based on polarization. And the point is the stuff going through the sides, which the force is always doing, is also doing the same thing. It's being polarized equal to the acceleration. So every change in the fish going forward means a change in the fish going through sideways. So a fish going through sideways is converted from a red fish to a blue fish. It still goes out the other side. There's still just as many fish in every location. It's just that they've changed their color. So I think that's a better image of what happens. So that could be a flat thing. So electrons could be pancakes and still cause change in the perpendicular direction by just changing the existing force, like a magnet, just changing the existing gravity that's going to the existing energy of gravity going through it, and it's just converting it by polarizing it into a more effective force because the other side of the magnet is sensitive to the kind of force the one side is producing. So one side produces a force that influences, it's exactly the opposite really. It produces a force that's invisible to the other pole of the magnet, therefore making gravity much stronger, and therefore pushing the two magnets together by nulling part of the meaning, creating frisbees all going straight line to the bars going straight up and down. So it's changing the frisbees from this to this. More of them go straight through the bars, meaning more of the matter is essentially invisible to any conversion issues, and therefore there's no acceleration in one direction, but the field has plenty of frisbees going flat, so there's plenty of acceleration coming from the other side. And vice versa, for two north poles of the magnet would be producing frisbees that are coming out exactly in the direction the other one is vulnerable to, that it will have to absorb, and therefore causing repulsion because there's more of the sensitive ones, the ones that are sensitive to being produced by the pole, by the filter. So I think that's the correct model. The magnet kind of demonstrates that you don't need to add any energy. You just need the existing field energy to be converted into a form that is, that causes the acceleration. So it's the existing gravity that's being utilized to push two magnets together, and there's no added force necessary. And it's just a change in the polarization that makes it relevant. And like I said, because it goes from a doubling the force to a nulling of a force, the effect ends up being a neutral to the actual gravity. So the gravity of the poles is neutralized because one side of the magnet is sensitive to one part of gravity, the other part's insensitive, and vice versa, and so it ends up being a net nothing. So if you could create a monopole, then you would have a gravity problem, but you won't be able to create the monopole so you won't have a gravity problem. All right. Yeah, so I'll still have to, I think it's really quite simple. I'm just not, because you have to do this in 3 dimensions, and that's what's slowing me down. And, but I mean, I think it's just that simple. It's just that the very idea of the spiral itself ends up creating a filter for anything going through it perpendicular. So you can sort of see that with a bicycle wheel. That certain things you would throw, like if the wheel's spinning, you could possibly throw a frisbee going on its edge through the spokes, but you wouldn't be able to throw one through if it's going flat, no matter what. I mean, there's always going to be spokes hitting it. You'll never get through, or you have some chance to get through if you throw the frisbee on edge. So I think that analogy is workable. So maybe I should write that down. It's a workable analogy. Frisbee as analogy. Bicycle wheel. All right, that should help. So no comments that I can see. And there's a link below. So like I said, somebody really has a horny for trying to defend quantum mechanics as anything but sometimes useful math. I mean, it's not as, they keep talking about like it's perfect or something, or it predicts everything. It does it. No, it doesn't. It predicts things that will not happen, like the photon hitting this thing actually just popped onto Pluto. That didn't happen. It's just a mathematical possibility, not a practical possibility. And it's just bullshit. Because they're actually, well, I mean, those PBS videos are so bad. I mean, there's the 2-slit one, and then there's the one on this very subject of quantum tunneling. And, it's, the guy just sits there with a straight face and basically says, well, first he does this thing where he basically converts the idea of a probability wave into a fact, into a real thing, rather than I mean, let's call it what it is. I mean, it was invented as a placeholder for our uncertainty, not for any absolute uncertainty, just for our uncertainty. And the uncertainty was always in a package that was reasonable. It was never uncertainty where, you could go anywhere in the universe with that uncertainty. So I don't know where they changed that, but somewhere in this mess, they went from a range. Like if I was shooting like the 2-slit experiment, they would have a range where they'd say, okay, the photon could be somewhere in this bubble. And somewhere in this bullshit, they went from this bubble to anywhere in the universe. And, that was real bullshit. There was a rational limit to the probability wave, and now they've made it an irrational probability wave. And I don't know what to blame for that, but that's made it just so much worse. I guess that's a multiverse necessity or something. But they're claiming now, they have like a 1994 experiment that you reference. And I'm saying they have an experiment from 1994 and they've never repeated it. That sounds a little bogus to me. I mean, it sounds like, this is supposed to be they've actually measured a single photon and measured a speed difference between the photon that traveled through, that magically tunneled through a mirror. So it tunneled through a mirror ended up on the other side, and ended up at the target faster because it tunneled through the mirror. And they say they've done this experiment, and in 1994. They don't have a more current experiment, a more accurate experiment, or more any. I mean, the very idea at first that you could think you could actually, that they can do this single photon thing, but the very idea of saying to me with a straight face that you now have proven that photons actually go through mirrors, which I don't think there's any evidence that that's ever happened, that photons just jump through the mirror. It's just bullshit. You know, it's like they keep, you know, to make this thing thin enough. You know, that's their excuse. We'll make it thin enough. Well, that means it has holes in it. So yeah, something could travel through something with holes in it. Yeah, that's possible. If you make matter thin enough, well, yeah, then things go through it that are small enough. But tunneling, no. Bullshit. Quantum tunneling. Oh, it's just horrible. So yeah, it's like they're just blowing up cause and effect as a fact. They really are running from that whole idea. And I didn't realize that that's what they were really up to, but that's really what they're up to. I wouldn't be a bit surprised if these people believe in free will or something. I don't know what the agenda is just so. These are clearly circumstances where you have two things to blame, right? So let's say you have a phenomenon where you have a hill, all right, a gully. It goes down, and the next hill is higher than the hill you're on. And so the theory is that, you know, for certain reactions to happen, the thing goes down and it goes up, but it doesn't have enough energy to go that little extra to get up that little higher hill. So that's sort of in nuclear physics and reactions and all this kind of stuff. So they're saying that the way it's getting around this other hill is that it goes through the hill. Now, the simpler explanation would be that, yes, this hill that's higher, that's the thing that has the probability. It's not always higher. It just averages higher. So the average amount of energy you need is higher than the energy you start with. But that's the average. So it means that sometimes it is lower, the second hill. So all you need to do is push it and it goes right over the hill because it sometimes is lower. So this is another thing where they keep picking the wrong thing as the reacting element. So when they turned light into photons into electromagnetic radiation, they did so in spite of the fact that they knew electrons did that. And the only way they ever see an expression, the only time you ever see a force express anything electrical or magnetic, is when the force interacts with an electron. Light travels all the way across the universe, billions of light years. It doesn't produce any magnetism or electricity. It doesn't produce any field energy emanating perpendicular from it. None. It just doesn't have these components. The electron has these components. The electron makes magnetism and electricity. The electricity being the movement of the electron, the magnetism being the perpendicular force release. And that's what is the actor, the electron. So, you know, they got it wrong. They just fundamentally didn't think about what it's like. The two-slit experiment will be the perfect example of this. Is instead of doing the logical thing and saying the material is diffracting the light, how close the photon is to the material will dictate how much the photon is diffracted, the simple explanation. They're going for this bizarre explanation that involves this magical photons that have all this radar and can do all these magical things and go through two slits at once and do all this bullshit. And the simple answer is obvious. It was almost obvious to Newton when he did Newton's rings. I mean, it was kind of basically saying, it seems kind of obvious that if you make the hole smaller, there's more surface as a percentage of the volume of the hole. So there's a higher likelihood of surface interaction by the photons. So yes, there's more diffraction. I mean, it is sensible, reasonable to conclude that it is the surface that's creating the phenomenon. And that you can clearly understand why a single surface, like I could hold up a piece of paper, all right, and we could say, well, how come there's a whole bunch of diffraction right here? Well, there is. It's just that you can't see it because it's getting washed out by all the extra light you're letting through over here. So all this extra light is washing out the effect, but the effect is happening on this edge. And it just is, it's multiplied when there's two slits because the two slits interact with each other. They're electrical fields, they're magnetic fields, they're static fields. Interact and magnify the effect, I think also. But I think this surface is actually doing that. It's just it's very hard to push a light over the horizon and just get the light that goes across the edge. The light source ends up being too bright, and you know, we know that the atmosphere scatters a ton of light, so you have to get rid of the atmosphere. So maybe you ought to maybe do a bubble jar experiment with a single surface and a very controlled light source and see what they can create. But I mean, I think you all know that that sort of happens. We sort of see that on edges of things that, you know, when the light just barely comes over the edge of a surface, it does this tremendous amount of diffraction. I think that's what they, you know, I think that's what, I mean, look, they have so much of it in their own instruments all the time. I mean, they see all these weird effects. It's like the stars with the light shooting out, you know, in their telescopes. I mean, they're getting an awful lot of this diffraction is happening without there being two slits anywhere. Just the circumference, just the edge of the telescope's lens, just the opening itself is, you know, causes these effects. So it's just all these wrong conclusions. So again, in this case of the amount of energy needed to break the electron barrier of an atom, instead of assuming that the thing not constant is the barrier around the atom, that the wall has weak spots. So instead of assuming the obvious, that the wall has weak spots, they want to say that cannonballs come in variety. You know, and it's just the wrong conclusion. No, the cannonballs are always the same. They don't do anything funky. They're really consistent. And the only thing that changes is you either have a thick wall or a thin wall. And so, you know, they had two places to place their uncertainty, two places to put their probabilistic mechanics of the fact that there's a cycle, that there's not a perfectly that the result isn't always 100% perfectly consistent. And instead of thinking the thing that's not always consistent is this complex thing, like the electron or the nucleus of an atom, instead of thinking of that as having some variety in it, they think the photon has the variety. Just completely wrong way to do physics and such. So is the chat not working? I'm surprised nobody said anything. Somebody could just say something just to indicate whether it's working. I guess I could do something, but it doesn't seem proper. So anyway, I'd really like to play a Ken video all the way through, but he just keeps repeating the same stuff, and there's not much you can say. I mean, this centripetal, centripetal, all this talk, and he doesn't really explain in any mechanical way how, you know, two magnets are attracted. And he's even saying there's no such thing as poles, and it isn't really attraction. And it seems pretty obvious that these things are attracted in the sense that they're obviously being pushed together, and you ought to have a mechanical mechanism that's doing that. I mean, this whole idea of just some kind of magical energy thing, you know, I just don't know why people find this at all satisfactory. I mean, this wacky explanation, like I say, it draws a picture. It's just the traditional mush of, well, there's a magnetic wave, and then there's an electrical wave, and it's like, well, how does that manifest, and how does that fly through space, and how does that make any fucking sense? I mean, it's obviously not manifested in a sine wave, so it probably has some other form, like it gets big and gets small or something in these different dimensions. I mean, you can almost think of it as a water drop getting fat one way and then thin the other way or something. But even that, you still got to say, well, what's causing that? It's got to have some sort of, it's complex behavior. You have to explain something complex. That's what physics is supposed to do, is break this stuff down to physical causes. And all you need is the first cause, which is the speed of light. And then once you understand that gravity isn't bent space, that it's an actual force, like photons, it exists, and that it can be converted into a form based on polarization that is more or less effective against something. Like I said, but the only reason why we see light is because it's at a frequency. Take away its frequency and you don't see it. So I mean, a bunch of photons could be coming at you. If I can stretch them enough or compress them enough, I'll make it disappear. You won't see it. It's still there though, right? You still know that if I convert red light into radio waves, you know the photons are still there. If I convert blue light into X-rays, you know you won't see them, but you know damn well they're gonna do damage to your body. They're still gonna hit you. They're still there. So seeing them doesn't mean anything. And so that was just another huge mistake, is to take the biggest source of energy in the universe, which is gravity, the biggest part of the field, what the field is mostly contains. It's one field. It's all just fish. And the fish can either be at a frequency of polarization, like blue fish here, and then there's another blue fish exactly 1 inch away, and another blue fish exactly 1 inch away, and that would be, you know, some form of light, photon, some sort of electromagnetic radiation. I hate saying electromagnetic radiation because it has nothing to do with electricity or magnetism. It's just a photon at a frequency. And so, yes, some of them can be at a frequency, and the rest of it's all mixed, and then you have this element of polarization. So that's it. You get three things. You get the speed of light, you have frequency, and you have polarization. That's all you got. The rest of it is just ton containing all or one of those components. And that's all there is. That's physics. That's an explanation that gets rudimentary, fundamental. You know, you just can't get any. It's as reductionistic as you can just about get. You can't even get any more reductionistic. You know, beyond coming up with a reason why what this thing is actually made out of and how it goes the speed of light. But beyond doing something impossible to do, which is give you that description, you've reduced it to as simple a thing as possible. You've reduced it to a thing just going one speed, heading in one direction, with a polarization. And the rest is just kinetic. So, yeah, so it's just disappointing that people can use all this complex rhetoric and all this bullshit, and you know, people swallow it. So they'll swallow Ken's hyperboloid, counter space, lack of inertia, which doesn't even make any sense. How can something have a lack of inertia? It's not really possible. You know, and they'll accept all this quantum jibber jabber of you know, a probability wave and, you know, quantums that are everywhere but nowhere at once, and they don't decide where they are until they get there. I mean, this really doesn't make any sense, right? They don't decide where they're going until they got there. Oh, when I get there, then I'll tell you where I was. I mean, does that sound like a rational physical explanation of reality? We'll know where we were once we get where we're going. Now, is that sounds horse carty to me, or cart horsey. Okay, hey is good enough. So there is a comment, hey, that's what you feed the horse. That is before the cart or after the cart. Yeah. The cart has hay in it and the horse is eating it. And that's physics. Dead, useless, unfunctional, completely wrong premised. So yeah, the rest of it's just really field talk. I mean, it's one big field. The rest of it's just local fields, and the local fields contain the distortions and polarization. The exchanges in the direction polarization is moving. Again, all the bits or all the fish still exist. They just go from being a flat fish swimming this way to a flat fish swimming this way. That's what matter does that to the fish. But when it does that to one fish, it does exactly the opposite to some other fish. So that's the catch. And it's just that it does one thing in one direction and does the other thing in the perpendicular direction. So it does these two actions that are exactly the opposite in exactly perpendicular directions. And that's the magic of matter. Yep. All right, so what else do I have to do here? So I like the idea of taking magnetism, and the ribbon analogy I think works well. So you could think of the bar magnet, you know, with the north and the south side. And what it really is the north side is it's like a ribbon. So if you took the atom itself, put it on edge, it starts off going this way and then it bends to the other side going this way. So if I twist a ribbon, it's that quarter turn, then I have a 90-degree, you know, I have a vertical edge here and I have a horizontal edge here. So if I take the horizontal and I turn it, I get a vertical going this way. And that's basically what a magnet is. It's just a filter, a twisted filter. So the atoms, I think, are actually doing that. I think I think it's not so much about where the electrons are. It's the fact that the atom isn't orbiting round. It's orbiting in this funny, you know, figure 80 kind of thing without the intersecting center. Well, it sort of does have the intersecting center. Yeah, kind of. I don't know how necessary that is, but I just mean it's doing this funky shape, I believe. So stuff that goes in one side of the atom comes out linear. Stuff going on the other side comes out horizontal. I mean vertical, horizontal. Kind of a thing. I believe it makes sense. So that's another analogy I think I'll be working with. I think that works for magnetism. All right, so I got that one for magnetism, and I got the spiked bicycle wheel. What do I call this? What is this word I wrote? Something Fisher, fresher, fresh. What did I write? That is so funny. I can't even read what I wrote. That's pitiful. Definitely start with an F. Frisbee. Oh, that's what it is. Frisbee. Yeah. Jesus. I couldn't read my E's, I guess. Frisbee. Just draw a picture of a frisbee. Solve the problem. All right. I would probably be better off in Egypt with hieroglyphics. I need picture words. Anyway. All right, so I think I covered what I need to cover here. I don't know if there's any point in going on too long. Did get delayed, so it is a shorter room, but yeah, there's not much participation, so I have to do something about that. Yeah, I have to get somebody to argue with. I'd rather just make video exchanges with people, but you have to find somebody willing to do that. And so far, there ain't nobody willing. At least in a rational way. I mean, half a day almost was useful a couple of times, but you know, it gets useless too often. So there are lots of questions to be answered, though. I mean, lots of curious things about the physical limitations. So, you know, we know that the sphere, you know, like the sun and Earth and planets, but those things have a limited size. You know, they don't get so big and then they don't get any bigger. They don't exist as a bigger object. And galaxies likewise. You see lots of big galaxies, but you don't see any little tiny galaxies. So there's certain structure that can't be maintained at any dimension because of these force rules of how much force it's capable of producing. I think is the real key to that. So I think the spherical thing breaks down because I think once you get a certain density of matter, it's dependent on the density, the atomic weight. You absorb all the gravity, essentially, and then the center of the body would have nothing to hold it together. The atoms themselves would fall apart. So it always would have to blow up because of its weight. So once it gets a certain atomic weight collected in a certain volume, it will absorb most of the gravity, or a sufficient enough percentage of the gravity will be absorbed in accelerating that matter and releasing perpendicular. And you just won't have enough energy to hold enough polarization. There's another tricky word here, to hold the center bits together. It'll be too filtered. And so the atoms will only be able to be in one form, one orientation. You have to think that one through. But I'm assuming it's some sort of limitation like that. It's just that there's only so much polarization to pull out of the field. It's only so many blue fish, so to speak. And once you've pulled all of them out, you've pulled all of them out. There's no more to pull out. You can't filter any more of them because they're all filtered out. And so I think that's the limitation. I would argue the same limitation exists for magnets, that you couldn't make a magnet actually the size of the Earth or something and have it still function proportional. It won't get stronger and stronger and stronger. There's a point where you make the magnet so big that the magnet can't filter any more stuff, so the filter stops filtering essentially, and any extra volume doesn't create any extra force because it can't create any more polarization. It's blocked out all the radiation. I suppose that's a way of thinking about it, is in the sense of like a shielding around a nuclear reactor. You make the shield really thin, it lets a lot of the radiation through, but there's a point where you make the shielding thick enough, it'll absorb all the radiation. And if you make it twice as thick as the point where it absorbed all of it, you're not going to gain anything from that extra. And there'll be no, if something needs radiation on the other side, it'll get none, and there'll be a consequence. But physics does nothing to explain any of that. I don't even think they have any, I don't think they have a rational definition. I don't think they have a rational understanding of galaxies even, because the way they talk about them, they continually talk about them as if they are solar systems, as if all the gravity is coming from the center. I don't think they really understand what's happening in galaxies, that it's the arms of the galaxies where the gravity is being generated. And yeah, I just don't think I get any of that. I mean, that's why they're looking for these speed differences. They want the center bits to be going much faster because that's what happens in solar systems, but that's not what galaxies are. The role that the mass in the center plays, it's much smaller than the role of the mass of the arms. The spokes are more important than the hub. The hub still exists, it's just not nearly like a sun in proportion to the solar system. It's like the solar system is much thicker, so the planets are making, so if you took this stuff you took the planets in our solar system and you multiplied it times 1,000,000, you could sort of get the idea that now there's a ton of mass in the solar system and that it's going to be the gravitational player, not so much the sun. And that's what's happening in galaxies. Galaxies have most of their mass is in the field of the galaxy, not the center of the galaxy. All right. Let's see. Sucks I just got here. Oh well. Well, you can always just watch the video tomorrow or something. And such. Yeah. I mean, I really should be able to do these on a schedule. It's just that especially in the summer, it's just hard to schedule time. I don't know what projects will occupy me and what jobs I have to do and this and that, so my time is less my own. I mean, I'm always free at midnight, but I mean, it's just, some days you're a lot more tired than others. So it's hard to commit to, and this is a harder conversation than just having some sort of philosophical conversation or political conversation. I mean, this is physics has got a lot of, especially dissecting their physics, because their physics has all this math in it and all this crap in it that you have to explain why that formula isn't a perfect representation of reality, and why what they're calling a real feature isn't a real thing. And so you do have to do an awful lot of this careful dissection to do this conversation in a useful way. I mean, you can't just naysay. You can't just say they're wrong. You have to explain why they're wrong, and it gets a little complicated. So it's a little bit more difficult to have the conversation, because you have to really do a lot more. I mean, it's work. You have to really think about this shit to be able to talk about it, I think, in a way where you can explain what it is you're seeing, what you understand. And like I said, especially just in the context, I have to interpret it first into their language, and I have to use their language and put it into my language and explain why their language is bullshit and why my word is the superior word. So it's, even the word particle is complicated because it's so misused, and the word light is complicated because it's a misunderstanding of what the difference between this form of force, which is light, and some other form of force, which has exactly the same function, does the same thing. It accelerates electrons just like light does. I mean, there's so many similarities. You're just like, how could they miss this? It seems like it's I hate to use that word obvious, but it's just so fucking obvious that these forces have so much in common, and not to understand light as a force, it's just such a mistake. Because it's all about accelerating an electron. It's all about an electron absorbing polarization in a direction and manifesting the illusion of movement, in the sense that the polarization as a collective moves. So the school of the fish don't move, the polarization moves. The number of fish going this way of that color is what's moving. Which, like I said, this makes the physical reality a little bit more complicated. It'd be nice to just say fish in, fish out, and that would be that simple, and then you're done. But it's not that simple. It's about this kind of fish in and this kind of fish out, and the fact that you have to do the exact opposite somewhere else. So it's really the conservation, not of energy, but the conservation of polar conversion. So let me write that down. Conservation of polar conversion. And what that really means is the orientation of the quanta. So it goes from being a quanta moving this way to a quanta moving this way. And that's what the filter of matter does. That's what the electron does. It takes stuff that's going this way and makes it into stuff going this way. And at the same time, makes stuff going this way go this way. So it just takes a blue fish going one way and makes it into a red fish, and then has a blue fish, converts a red fish into a blue fish the other way. I mean, it's just that simple. And that's the whole foundation of the universe. All right, this partially through the mulling over the good facts and the goofy facts sounds like quite a task. Yeah, well, I don't think they have too many good ones, actually. I mean, when you really listen to it. I mean, some of the formulas are reasonable in the sense that they recognize basic rules. It's like even Einstein's, I mean, Einstein's addition to Newton is a tiny addition, but it's an incredibly complex addition because the complexity is in all the little movements. So what Einstein is accounting for in his math is the fact that the sun is being moved by Mercury's gravity. See, Newton's model just took the sun as a static and really just dealt with the sun's effect on Mercury. But the trick is no, there's a real effect of Mercury on the sun. And so the sun is actually moving its center of gravity based on Mercury. And so that's the real complex motion, because as the Mercury moves, the sun is orbiting its center of gravity. And so you really have two things orbiting. So Newton's math was really only trying to describe one orbit. When to describe the one orbit, you really have to describe the orbit of the sun around its center of gravity. And that's what, and technically you could almost say Mercury might have a little bit of a wobble in its center of gravity also, especially if it had a moon. But, that's all that Einstein added, though. It's just this nuance of the fact that there is a tiny, tiny, tiny bit of orbiting that the sun is doing around its own center of gravity because of the gravitational pull of Mercury. And so that's what, so yeah, these are good equations, but they're conceptually wrong because, yes, they have this stupid thing where they make time a dimension, and that's idiotic, and space a dimension, that's idiotic. These are not places. Time is a function and space is nothing. And gravity is something, and it's not bent space, it's a force, and it exists in the universe before all the other forces. It's the first cause. Anyway, is there a flip that happens somewhere midway during that conversion? Is there a flip that happens somewhere midway between the conversion? Well, I think the point is that the conversion is complete. So it's all, I mean, we know that the force is emitted, electricity, magnetism, we know that that force is always emitted perpendicular to the velocity of the charge. So as to the acceleration. So as you accelerate a charge, an electron, the polarized force of magnetism, the EMF, the electromagnetic force emitted, is always perpendicular. So I think it's always a complete flip. I mean, it's a geometric, algebraic thing. It just doesn't have a midway thing. It flips, completely. It's a complete exchange. Let me just put it that way. So I think the rule is that two things have to hit each other that are perpendicular. So a blue fish has to hit a red fish for this event to happen, where the blue fish, the blue goes out where the red came from, and the red goes where the blue came from. So there's a certain special way that you hit two things together. If you hit two things together this way, they go right through each other technically, because they just perfectly bounce. So it's the same thing as going right through each other. And if they hit this way, they do the same thing. They just perfectly go right through each other. So it's only certain interactions that create this reverse effect where the universe is now changed, where this didn't continue to go through this. So the kinetic rule is broken, and this ends up going off like this. And where you had polarization this way going this way, now it's not going that way, now it's going this way. So I'm just saying that that part of it seems a complete conversion. Yeah, well, the filter is just the idea of the alignment. And like I said, if you think about something, you think about the smallest elements of matter being able to do this ribbon thing where you just twist the ribbon, or twist the piece of paper. Well, it didn't work very well. It stays horizontal at one end and it goes vertical at the other end. You can sort of see that effect would be filterish. Like if I piled a bunch of these on top of each other, you could see that this would create a bunch of horizontal bars, and this would create a bunch of vertical bars going this way. So the two filters at the two ends would be exactly the opposite. Horizontal filter here, vertical filter here. And that's kind of what's happening with a magnet. I think it's exactly what's happening, but I gotta be careful not to say that. You know, but yeah, I'll have to cut some smaller pieces of paper and do some ribbon experiments. But I was trying to think of it. It'd be kind of neat if I could just do, you know, if I could make plastic pieces like that I could put on top of each other and stack and make into something, and then I could really see how it could work if they're all stacked in certain ways. How you end up with tunnels where it just keeps spinning around and around and around. You know, it keeps flipping from this to this to this to this. You know, so. But I think that's how the magnet's working. I think. So yeah, thanks for the feedback. But yeah, you say goofy facts. Like I say, you know, they're calling Heisenberg a fact. They're saying that photons don't have a location. You know, they're basically destroying its material reality, its factual reality. And you know, because we can't identify where it is, we can't test where it is. But I think we always know it travels the path. I mean, I think, you know, I just don't think there should be any logical argument that if you think about a photon traveling 15 billion light years across space, I think you know the photon didn't go to the moon and then go to Venus and then go over here and then go over here and then go over there and go over here. And go. I think you know that the only way it got from where it was to where we are is in a fucking straight line. It didn't do any of this bullshit. And, you know, it's just so irritating. That, and of course, if it hits an electron, that's it. It has to be readmitted. It's a new photon. It's not the same photon. So, of course, its story, it's collapsed. And there's a new story now. And that's what's happening in the double slit experiment, is the photons are traveling through the field of electrons around the surface. There's a field of electrons around the surface of everything. Every material object has electrons on the surface, and they have fields of them because protons are saying, I like electrons. You know, that effect is there, but the electrons hate each other. So the electrons pile up like people outside of a store waiting to get in or something. Except they hate each other, so they keep distance from each other. But anyway, so there's a field of electrons around all material objects. And clearly the electrons, the photons are going through the two-slit experiment. The ones that get diffracted, they're clearly hitting electrons to get diffracted. So yes, they're collapsing in the sense that the photon is being interrupted, and the electron is emitting a new photon at a slightly different trajectory. I mean, it just seems perfectly reasonable that that would be the explanation. Well, a helix is a little more complicated, but yeah, I mean, the idea of a swirl and a whirlpool and all that are nice ideas. I'm just saying that you have to convert them into some kind of real thing that makes the fluid, you know what I mean? So then you have to create an ether, and an ether gets really complicated. So I don't think that's worth messing with, personally. And I think it is just polarization. So I think you'd never say that if a bunch of frisbees were flying at you in a pattern, you know, whatever the pattern would be, you wouldn't call it some kind of pattern. You know what I mean? You know that it was a pattern created by a mechanism that was shooting them out in a certain way. You know, it's like the spin on a baseball or something. You just don't. You know, it can create wind resistance based on the spin, and that can drive the ball in a direction depending on the humidity of the air. But you know, it's not something you would say was the major player. I don't even know if being a scientist anymore is a good word, right? Because so many scientists are so full of shit. It's almost like you almost don't want to be a scientist, or called one, because it seems like everybody who's declared one, frankly, is a theologist. I mean, this really is their whole standard model, their whole underlying physics. It's all theology. It's all a dogma. The fact that they've never repeated the Einstein lensing experiment. I mean, it's fundamental. Again, and that they would cite in a quantum tunneling video, they would cite a 1994 experiment where they supposedly, used single photons and proved that the photons arrived at a target at a different time in 1994, and that they don't have a new version of that experiment. No one's repeated the experiment again, another unrepeated experiment, with making a huge statement, which essentially is the photon moved faster than the speed of light. I mean, that's pretty much the claim. They're saying by jumping through the mirror, by tunneling, by jumping through, the jump was instantaneous. The photon didn't have to use any speed of light time to get through the mirror. And I think that's obvious crap. I mean, I think it's reasonably suspect. Let me put it that way. It's reasonably suspect as a premise for a theory. But it's everywhere. I mean, all of them, if they're not talking quantum bullshit, then they're talking, black holes and lensing and dark matter and dark energy and swirly bits and collapsy bits and, all kinds of just absolute crap. And I think crap that's just so easily demonstrated to be crap. I mean, I think I've dissected the lensing thing and just shown how it's such a fraud. And I think I could do it with their what the arguments they're making about the speed of stuff inside of galaxies. I just think it's so obvious they're not getting the obvious. That the motion of the suns inside of galaxies is a lot more complicated than the motion of planets. The suns sometimes are moving exactly the opposite direction that the galaxy is spinning, because they're moving towards the center of the arms. Well, let me put it this way. They're orbiting the center of the arms. I should have said it that way. Obviously, they'd lose their shape really quickly if they were going in linear direction right for the center. So they're obviously orbiting the spiral arm. Something that's kind of annoying about cosmology is that because the Hubble's getting kind of old now, you think they'd have a lot of pictures of, time-lapse pictures. And there's so few of those, like where they take a picture of the same place in space, once a week, I guess, for 10 years, and you get this idea of something really changing. And they don't really do any of that. And it's kind of annoying that they really don't have, exactly the same focal length image, the same picture of the same place, 10 years ago, 7 years ago, 5 years ago, 3 years ago, that kind of thing. So little of that. maybe it's because of modern media outlets and the internet. Well, I'm just saying, a lack of integrity is a lack of integrity, and making any excuses for what are perversions and distortions and grandiose claims. I mean, just preposterous exaggerations. The whole Young thing, like the Young experiment proves light's a wave, and it's just that's just bullshit. I mean, they want it to be proof, but it's not proof. I mean, these are people who want OJ to be guilty, and of course, they're just exaggerating everything. Of course, OJ's guilty, but I'm just saying I should use some other example where these are people who don't want OJ to be guilty, so they're trying to find any excuse possible to, pretend there's some other explanation. Making grandiose, unscientific statements like cloaked as a scientist. The public eats it up. Well, again, they're not just cloaked as scientists. These people win Nobel Prizes and shit and still talk crap. But yeah, I didn't realize, like I said, this has been I thought physicists were smart, and frankly, I don't think they have. I think they have less intellectual integrity. I can't think of a science that has more false, just obviously exaggerated claims of proof and evidence. How many of these people have said it's the most proven theory in the history of mankind, for quantum mechanics, and it doesn't even mathematically accurately describe the two-slit experiment. I mean, their foundational experiment isn't even accurately described. They've never proven the existence of bent space. They've never proven the existence of a black hole, and they just keep talking about them like they're proven things. They actually are real. They do exist. It's funny they don't reproduce that experiment, because I've heard in philosophy of science that talk of reproducibility is a large tenet of science, which distinguishes it from pseudoscience. Yes, it is a huge... I was amazed when I did this research on it, and I'm just, and then like I said, and then it occurred to me that the Hubble telescope overcomes why they had to do this. They had to do this thing when there was an eclipse, and so yeah, you can understand why it's not a very easy experiment to reproduce, because you have to do it when there's an eclipse. So yeah, that's sort of a pain in the ass. But there is an eclipse somewhere, like every 5 years or something, right? I mean, a total eclipse, there's one somewhere like all the time. So it's not like it's that hard. But yeah, the fact that they've only 2 other times they tried doing it, and both times they fucked up enough where the results are incredibly useless. But the truth is that the Hubble telescope eliminates the problem. You don't need the eclipse anymore. You can detect lensing anytime you want to, because there's no atmospheric scattering. And the fact that we don't have any reports from Hubble of solar lensing is a gaping, obvious problem with Einstein's prediction. His prediction is wrong. I mean, it's not there. Obviously, the lensing isn't there, or they'd show you a picture of it, a high-resolution picture of it. But it's odd that what was considered science has been going on way before philosophers giving rationales on what is science and not. Yeah, well, it's all the same thing. I don't really consider philosophy not science. So to me, it's all the same thing. You're trying to accurately describe reality. And that's in my opinion, that's the only useful intellectual function, is to try to accurately describe, use words, and make accurate statements about reality. So making accurate statements about reality, in my opinion, is the objective of both science and philosophy. So you try to discover the truth and then accurately state the truth. And that's all it's about. Obviously, the hard science of the materials, the sciences more involved with describing the material reality have harder evidence to use. They have, they can take a picture of something, where it's a little harder to take a picture of a philosophical concept. But frankly, you can draw the picture of the philosophical concept. I mean, you can rip my face off, virtually, and rip your face off, and we could both see that we're just blood and bones and sinew and brain, and that this facade that we wear doesn't mean anything, that the real definition of what we are is this, sensing organs. But yeah, I mean, I think a good philosopher or a good scientist it's really all they're really doing is trying to accurately state the truth, and you have to do that in this context of what is truth, and truth is really the strength of your facts, right? I mean, the strength of your evidence. And so what you really want to do is point out how the evidence points in a way and that it can't possibly point somewhere else. So when they say they have proof and they haven't discounted the alternative explanation, which is the electron did it, instead of saying the photon's doing this, and I can alternatively say, no, the electron's doing that when the photon hits it. They haven't proven that my theory is impossible. They've just neglected to even deal with the alternative theories. They found the theory they like because it's mysterious and makes it all kind of magical. And, the counter theory that's solid, that has to do with real facts, that's consistent with all the facts, is the one they run away from. It's just so bad. Something like that, yeah. Everyone has a smile when they don't have a face. Well, yeah. Yeah, I don't, it's not a friendly smile, though, or something like that. But I just mean that for philosophy, you can get to the philosophical truth by kind of materially, in the sense that you can understand concepts as being solid, like the idea that we do feel, or the idea that we see, or these are real things that are happening, and you can. So there is materiality to a philosophical conversation. It just gets a little harder to explain value because of the nature of its formation, which is illusionary, which is contained inside of a perception space that doesn't seem to have a visible arena. I mean, the arena is quite obviously there because we see it inside, we feel it inside. So the arena is there. It just can't be seen by any kind of mechanism where you can say, I can see, your sensitivity. I can see your pain. You just can't take a picture of it. And the inside, but we can know they exist. And I guess that's the point that matters, is that we can establish the fact of the phenomenon, and then we can talk about how the phenomenon has meaning. And I think do that in just as rational a way as you would talk about a photon's interaction with an electron. I think both are just as real a conversation. Yeah, I don't know why these emoticons have gotten all flat-bottomed. It's just I don't know if I like gumdrop emoticon. I think round was a better shape, but it might be to my purpose to have misshapen circles because that kind of goes with my physics. And such. So anyway, I suppose I've done enough damage for the evening. Yeah, I'll try to get something. I'll try to stay on one subject and beat the shit out of it. But I don't know. I'm trying. I just, just takes so much time to get through all this stuff and try to find the parts that are hanging points for other people, because you have to keep going back to the beginning, and I have to do that in I have to do it all in some kind of really slick, quick, concise way, but it's really hard to do that, and that's a little bit irritating. It's like the whole gravity argument. It was really nice 6 months ago when I was thinking of it more like a push, and things were accelerated by the push. But once you force it to be an absorption, acceleration is the absorption of energy, of force, and then you turn it into, no, it's not really absorbing actual fish, it's just absorbing polarization, so now you're 2 levels removed from that simple explanation. It just says, look, there's more fish on the outside than there are the inside, it moves towards the inside, but it's more complicated in terms of what's actually moving. It's just a field of polarization. So, that tricky little nuance makes the whole thing less fun to explain, because it's so much easier to explain it as just fish, pushing things. But that's cheating the truth, so I have to deal with the more complex fact. I just have to make the more complex fact just as palatable. So anyway, thanks for the comments, and we'll try again next time. I'm going to do like I said, the PBS video. I'm going to do. It's such a bad video. It's titled. I'm really hating their videos. Like I said, the one on quantum tunneling is so bad. And so this one's called the quantum experiment that broke reality. And it's really just a description of the 2-slit experiment. And they've turned it into this complete bullshit. What the hell is this, an ad? They're playing an ad? Ugh, PBS has really gotten annoying. Anyway, I mean, it just ain't the old PBS, right? But nothing's the old anything. I'm not the young was me. So, everything goes to hell, I guess. Sort of. Mostly. Alright, save that for later. And where's the room? Here's the room, I think. Okay, so I got that. Alright, so yeah, thanks and such, and till the next time. And like I said, I'll do a response to that video, and then I'll open a room probably in a day or two, and maybe talks about the key points or something. I mean, I know I've beaten that experiment to death, but it's so fundamental to this whole quantum theory crap, and it's such a bad experiment to use as an excuse for creating this wave notion of reality. It really is horrible, terrible, awful science, and such. So I grabbed the chat, I think, so I'll post that later. All right, so till next time, and such, and so forth, and whatnot.